Have you ever looked up at the night sky and seen it move? Imagine silent ribbons of green, pink, purple light swaying gently across a sea of stars. This is the Aurora Borealis, the Northern Lights, a celestial ballet that has captivated humans for thousands of years. People across the globe brave polar cold, tell stories, paint pictures, and wait in wonder. But what is this magical glow? The answer is not magic, but a beautiful story of science. It is a sign of powerful, unseen forces that shape and protect our world every day. The story begins 150 million kilometers away with our star, the Sun. Streams of energetic particles, an invisible magnetic shield, and the air we breathe fit together like a cosmic puzzle. Come with me as we pull back the curtain and see why the Northern Lights glow. Our journey begins with the Sun, the center of our solar system. A gigantic ball of hot gas, its surface churns with immense energy. Great loops erupt in solar flares, releasing powerful radiation and energy into space. Beyond the outbursts, there is a constant flow of particles, the solar wind, mostly protons and electrons, traveling at over 1 million miles per hour, carrying the Sun's magnetic field. An invisible river that blows through the solar system and toward Earth. Sometimes it releases a giant storm cloud, a CME, a billion-ton cannonball of plasma. Aimed at Earth, CMEs drive geomagnetic storms and spectacular auroras. Think of it as the sun breathing, usually a gentle wind, sometimes a powerful sneeze. These particles begin a long journey. Some head straight for our planet. As the solar wind races toward us, it meets an obstacle. Deep inside, our molten core acts like a giant dynamo, generating a magnetic field. This invisible field extends into space, forming the magnetosphere, our first line of defense. Like water diverting around rock, most charged particles are smoothly deflected. The shield compresses sunward and stretches into a long tail on the night side. It is not a sealed bubble. Open field lines near the poles act like funnels. Some particles get trapped, spiraling along magnetic lines like beads on a wire. The field protects and also guides a small fraction down into the auroral ovals. After millions of kilometers, they begin a high-speed dive into thin air. The stage is set. The finale will light up the night. Guided by Earth's field, the particles hurtle into the top of our atmosphere. It seems empty, but nitrogen and oxygen are there, just far more spread out. This is not a gentle bump, it is a high-energy collision. A solar particle transfers energy to an atmospheric atom or molecule. Electrons are kicked upward, like striking a bell and setting it ringing. Atoms cannot stay excited. As they relax, they release the extra energy. They emit a tiny packet of light, a photon. This is the essence of aurora. One flash is faint, but trillions upon trillions happen across a huge sky. All those microflashes combine into the dancing curtains we see. The solar particle's long journey ends in a brilliant burst of light. Aurora colors depend on which gas is struck and at what altitude. The main players are oxygen and nitrogen, each with its own signature light. The most common color is pale green from oxygen, typically 100 to 240 kilometers up. Oxygen there takes about a second to glow before colliding again, producing vivid green sheets. Above 240 kilometers, thin air lets oxygen emit slow, rare, deep red light. Nitrogen releases energy faster, adding pinks, magentas, and occasional blues along the base. During strong storms, particles penetrate deeper. Pinks, blues, and purples grow vivid. Atmospheric chemistry becomes a rich palette, painting the night. Each gas rings its own color, its unique spectral signature released as photons. Together, they create the masterpiece we call the Northern Lights. To witness the lights, be under the auroral oval, high-latitude regions. Norway, Sweden, Finland, Iceland, and Greenland are prime. In North America, Northern Canada, Yukon, Northwest Territories, and Alaska, you need darkness. Best from late August to early April, especially around midnight. Patience is key. Many wait hours for the first faint green glow. Agencies track CMEs and solar wind. The KP index from 0 to 9 signals storm strength. Higher KP means stronger storms and auroras visible farther from the poles. Dress in insulated layers, waterproof boots, hat, gloves, scarf, and bring a hot drink and snacks. Consider a guided tour. They know safe, dark sky locations away from light pollution. With the right place, time, and prep, the sky rewards your patience. From the sun's fiery heart to our silent upper air, the aurora tells a story of connection. Particles cross millions of kilometers to meet Earth's invisible shield. The magnetosphere protects most, but guides a few down toward the poles. Collisions transfer energy. Relaxing atoms release photons, the spark that lights the sky. Oxygen paints greens and rare reds. Nitrogen adds pinks, blues, and purples. Billions of tiny flashes merge into shimmering curtains of light. Aurora intensity follows the sun's rhythm. More storms at solar maximum, more light shows for us. We can forecast the dance, but seeing it connects us to the sun and the fabric of space. Respect these wild, fragile places where the magic happens. The northern lights are a visible reminder of the deep harmony of the cosmos. For more such videos, share and subscribe and press the bell icon.